Okay, so I got this kilograms into pounds by doing this conversion times divide. What makes more sense, the price per pound or the pounds per dollar? What makes more sense in a store? Price per pound. So I'm going to put the price on the top. That's the price per that many pounds. So how much money would that be for 1 pound? So you just divide. This is what we would call a unit price. Okay, and then compare with the other one. So you have to get them into the same units. That's the biggest thing. Once you do, then I would say that's cheaper. Okay. 2 racers are figuring out who's faster. We have a kilometers per minute, and then we have miles and hours. So first of all, let's talk kilometers and miles. What do we want to be in? Doesn't matter. You just pick one. Kilometers we're going to go. So 3 miles I'm going to now make into kilometers. That's what we're picking. And then I find something and I write. So I'm going to go 1 mile equals 1.61 kilometers times and divide. Okay, so the first person is 4.83 kilometers. No, what am I doing here? 4.8, and then the other person is 5 kilometers. Okay, and now I have a problem with the minutes and the hours. Turn it into minutes. We could. It'll make a really awkward number because thinking about how many kilometers you run in a minute, that's pretty small, right? Probably hours would make more sense. If you ever asked a racer, would they ever tell you how many kilometers they can run in a minute? Probably not, right? So I'm going to go with the hours. So this one is already 0.4 hours. How do you turn minutes into hours? Divide by 60. And I'm going to just do that all at once in no rounding. With brackets though, right? So who would be faster? Okay, so what do we need? Do we need anything on your cheat sheet at this point? You tell yourself. Anything with time conversion? How did I get the 12? Did you get something different? 4.83 divided by 0.4. Oh, you times, yeah. divide. Kilometers per hour, divide. Right, this is less than a half hour, so they're obviously gonna at least double that. Okay, reading a chart about rates. Where is the plane descending the fastest rate? What do you just look for? Fastest rate? Steepest? Where are we the steepest? C to D. So that's the hint with rates. The fastest is the steepest line. What is going on with the airplane over the interval B to C? It's not going down, it's just flying flat. It's flying flat at that point, it's not descending. Determine the exact rate in C to D. Okay, so first of all, I have to figure out in this interval how much did this point and this point, how much did it move down? This height was 2,000 and this height was 0. So that's minus 2,000 because it's going down. Minus 2,000, what are we in, feet? And in that interval, how much time elapsed? So this is at the 35-minute mark, and this is at the 45-minute mark, so 10 minutes. So if I wanted a rate, it usually means per one thing, right? Per minute. So you're going down 200 feet per minute. Okay, you can type 36 words a minute. The teacher gives you the rest of class, which is 43 minutes and 20 seconds. 41 minutes. What did I say? 30? 43. I don't even know why I said that. And you are going to try to get 1,000 words in. Are you going to make it? What do you want to do? We have two options. We could do how many words would we type in that time, or we could do how long would 1,000 words take us. What do you want to do? You can do it either way.
How much time for 1,000 words?
1,000 words equals how much time? We're going to figure that out. Okay, so 1,000 words is how much time when I know 36 words is 1 minute. So if I times and divide, I will get an answer, obviously in a minute form, right? 27.78 minutes. So will you make it? Yes, because yes, because you're under, you were under that time. So yep, it's going to be okay. Okay, I need you to write this on your cheat sheet. I need diagram to real is a scale. You always write it diagram to real. Okay, so here we go. The thickness of a coin is this much, and the diagram is that much. First of all, we got to be in the same units. What do you want to do? Everything centimeters or everything millimeters? I think that it'll be millimeters would be a little bit easier. Okay, times 10. So diagram is now this one to the real. Now, here's my cheat sheet. I'm going to make the smaller one a 1. Which number is smaller? Obviously the 1.95, I'm going to make a 1. And then I'm going to multiply, divide. So the scale used is 15 to 1, which means my diagram is blown up. My diagram is bigger than the real life object, right? Because the thickness of a coin is pretty small. So when I drew it bigger. If you want to write that on your cheat sheet, this would mean the diagram is bigger. Okay, a bedroom has this width, the diagram is this. What scale factor was used? What's easier to go? Feet to inches or inches to feet? Feet to inches. I'm going to times by 12. Okay. Diagram to real. How do you write it? So diagram was this, real life was this. Did everybody write this on their cheat sheet? Make the smaller one a 1. So which one of these will I turn into the 1? 18 times and divide. If you do want to add something to your cheat sheet, when it's written like this, 1 to 8, it means the real life thing is 8 times larger than your drawing, which makes sense because a bedroom, right, your paper version of the bedroom is smaller than the real bedroom. Okay, for right now, I'm just going to skip a little bit here because I want to make sure I get some stuff on your cheat sheet here. Okay, this has to be on your cheat sheet. Your area Or what, how did we write it? I feel like we wrote it really nicely somehow. What did I do? Linear scale factor. To go to the area scale factor, you square it. But to go back, you do what? Square root it. Remember a linear scale factor and an area scale factor? And then we had linear scale factors and we talked about volume. What do you think we did to get that? How do you go from a linear to a volume? Cube it. How would you go from a volume to a linear dimension? You would cube root. So linear to a volume is cube, and then obviously going in the other direction, cube root it. Okay, let's check out Chad. They did painted a mural on their wall measuring this. So if the mural is that dimension, it has an area of that. The original area was that. Oh, I'm in inches squared. Okay, I probably won't put that on an exam, so just put that in 1 feet squared, 1.5 squared feet. Okay, so this is that. Okay, how do you do scales? It's always we need to write this. A scale is always new divided by original. That needs to go on your cheat sheet. Your scale that you write is always your new divided by original. Okay, so painting the mural, we had the new area was 96 and the original area was 1.5, which is 64. So the mural was blown up 64 times greater in area . So the dimensions are how much times bigger. What do I do? This is an area scale factor. That's how much times bigger the area is. What do? You're in area. So you need to square root that. So the sides are 8 times bigger, right? Do you remember doing something like that? Okay, so a circle had a diameter of 56 and then it turned into 7. So new divided by original The new is 7 and the original is 56. So the scale is 0.125. Do you remember this as well? If that number is below 1, it's a reduction. Something you did, you shrunk it. So this is a linear, right? Because the diameter is linear. So what did the area change by? How do I go from linear to area? I square it. That's how much times the area would be smaller than it's smaller than it's shrunk, right? The area is that much times smaller.